Right, there are a couple of different ways to tackle this problem. We have to apply this matrix to these coordinates and then describe the transformation that the matrix represents. Now what we could do to work out each of them, I've just written this out here. Each point I've got A dash, the image of A. Well, I've taken 1, 0 and I've applied, I've written that there, and I've applied this matrix to it by putting it in front of it, and I've worked out the vector to that point in question. So that would be, for instance, negative 1, 0, and then I could plot that, and then I could see what that looked like, and then do the rest for the in the same way. That's fine. However, I'm just looking at this matrix, and I realise that each time that we try and show a combined each time we try and show a transformation, it's about what we did to the vector OA to begin with. So you remember, each time we have, for instance, OA, we have a little arrow, don't we? And then that whatever goes here goes first in our vector. So really, what's happening is 1, 0 has become negative 1, 0. That's what that means. And the second one that we always do is 0, 1, the journey between O and C. So 0, 1 becomes 0, 1. So 0, 1 is unchanged. So our vector between O and A was 1, 0, and now it's negative 1, 0. So A is going to appear down here. Sorry, A dash is going to appear there, and C, OC is going to remain unchanged. So C dash is going to remain in the same place, in that position up there. You can imagine that B dash is going to appear over here. And sure enough, in my other method that I did before, B dash is negative 1, 1. So I think this method is simpler, but you can use that method to remain consistent with before. Okay, so describe the transformation that this represents. So C hasn't changed, O hasn't changed, so everything that's on the y-axis hasn't changed. The B has gone over here and the A has gone over here, so this is a reflection. None of them have switched positions, so it's not a rotation. So it is for question 1, a reflection. And as I said, it's a reflection in the y-axis. Now it is possible you could have memorised this and realised that this is always a reflection in the y-axis. So you could go straight to that point, but I think it makes it clear when you draw the diagram. Number 2, work out p squared. So that's p. And p squared is going to be negative 1, 0, 0, 1. So p squared is going to be that times by itself. P times p. So we are going to do that times that. That's 1 plus that times that, which is 0. So that's 1. Negative 1 times 0 plus 0 times 1, that's 0. 0 times negative 1 plus 1 times 0, that's 0. 0 times 0 plus 0 plus 1 times 1, that's 1. So that's p squared. Question 3. Use your transformations to interpret your answers to 2. Well, you may recognise this thing here. This is called the identity matrix. So this is I, which means that it doesn't do anything. It's back to the original shape. And if you think about it, if you're going to do a reflection in the y-axis from here to here, and then you're going to reflect in the y-axis again, which is what this matrix does, you're going to reflect back to here. So you're going to get back to the original point, which is why we've ended up with the identity matrix, meaning that we've got back to the start. So how do we put this? We could say that a reflection in the y-axis followed by a reflection in the y-axis, gets us back to the original position.